Hi, my name is Ivan Font, and this is a presentation on exploring application portability across clouds using Kubernetes. This is a post-Red Hat Summit recording that we presented during Summit. So first, some background. So we are part of the Emerging Technologies group within the Office of the CTO at Red Hat, and our charter is to build prototypes and run exploratory projects to inform Red Hat's long-term technology strategy. At times, these will evolve into new product features or products. We also develop a point of view on new emerging technologies and work with product teams to build alignment on that technology strategy. So this presentation is intended to give you some insight into an exploratory project that we are currently working on. And as always, this is all open source. So what's the problem that we're trying to address here? Well, let's say you have an application that is running on a particular infrastructure on a particular cloud provider, for example, Microsoft Azure, and you would like to move it to a different infrastructure running on a different cloud provider, for example, Amazon Web Services. Well, what are some of the challenges that you're going to face? First, how do you have Kubernetes automate this for you? How do you make sure you don't lose any data? And how do you maintain uptime? Well, these are the questions that we're looking to address. In order to address those questions, we had to build a reference web application. And we love Pac-Man, so we chose Pac-Man. We added a stateful component to be able to persist the high score and the live stats information as you're playing the game into a MongoDB database. And we also modified Pac-Man to detect and reflect the cloud provider that it's running on. And we'll see that a little bit later. We then containerized Pac-Man and deployed it along with containerized MongoDB onto a Kubernetes cluster. And this is what the current state looks like right now that we'll show here soon. But first, let me talk about the deployment on how we got here. So you can see here that we have two clusters. We first started with a Kubernetes cluster running on Google Cloud Platform. And then we deployed the Federation version 2 control plane onto that Kubernetes cluster, along with a cluster registry to register that cluster with the Federation. Now, if you're not familiar with Federation, this is basically a new project under the Kubernetes SIGs organization called Federation version 2. And it basically allows you to manage your resources across multiple clusters. So once we deployed the Federation version 2 control plane, we then used it to deploy Pac-Man onto it. And then once we had Pac-Man running on the Kubernetes cluster on Google's cloud, we then said, all right, let's see if we can add another Kubernetes cluster. So we then added a Kubernetes cluster running on Microsoft Azure, and then added it and registered it with the Federation version 2 control plane. And we then used the control plane to deploy Pac-Man onto this additional cluster. We then have one entry point URL that will randomly resolve based on your DNS client to point to one of the services for Pac-Man being served out of one of these clusters. So that's our current load balancing implementation here. So let's take a look at what that currently looks like. So I'm going to run a command here. And basically, this command is just a wrapper around the kube control command that will iterate over the registered clusters and run some kube control commands. So here we want to run a get pods. And you can see that we have one cluster here. This is our Google Cloud Platform Kubernetes cluster. And there are 5 instances of Pac-Man running on it. We then also have a cluster here running on Microsoft Azure, and we have 3 instances of Pac-Man running. We also have an additional Kubernetes cluster running on Amazon Web Services. Here you can see that there are no resources that are running in that cluster. And we'll come back to that a little bit later. So you may be asking yourself, well, why are there 5 Pac-Man instances running on Google's cloud and only 3 on Azure? Well, let's take a look a little bit at what the deployment looks like for that. So in order to deploy Pac-Man, the Federation version 2 control plane introduces a new federated deployment resource type, and in it, it basically embeds a Kubernetes deployment resource type. And here we specify that we want 3 replicas. The other stuff is basically also just some standard Kubernetes deployment spec information, such as like we want the name to be Pac-Man and the namespace to be Pac-Man. We then also have another resource type supported by the Federation version 2 control plane called Federated Deployment Override. And this resource type allows you to basically differentiate certain parameters from one cluster to another. So for example here, it provides the ability to override a certain parameter. We're specifying that in our Google Cloud Platform cluster named GKE US 1, we would like to override the replicas and specify that we want 5 instead of the 3 that's specified here in the default federated deployment template. So that's why you see 5 replicas running on Google's cloud and only 3 on Azure's. So let's go ahead and play the game and see what it looks like. So first on the left here, we have some live stats, and it'll update about every 10 seconds or so to show you the current stats of a user playing. And on the right here, we have the actual game itself that we'll be playing. But first up here, you can see that there's a cloud field, and it's specifying that we are talking to the Google Cloud Platform provider. So this will indicate the cloud provider that we're running on. Similarly, it's also going to show the other cloud providers as we move forward, and we'll show that. And it also shows some other information like the zone, US West 1B, since this is the zone that the Kubernetes cluster is hosted in. So let's go ahead and play around. And we'll just collect some score here. And you can see that the live stats was updated there on the left, showing the current round here and some of the stats. So let's go ahead and die. And we'll save this as Ivan1. And we can view the high score here and see that Ivan1 was persisted running on Google's cloud platform and with a high score of 800. So if we refresh this, you can now see that the DNS resolved and we're now talking to the Pac-Man running on Microsoft Azure's cloud. Similarly, let's go ahead and play around. And you can see that Microsoft Azure instance on the left there is updated to show the live stats for this instance of the game. Save this as Ivan2. And we can view the high score, and we can see that Ivan2 was persisted here, running on Microsoft Azure's cloud with a high score of 720. So you saw that we can now play the game on the cloud providers, Google's Cloud and Microsoft Azure, and you can see that Pac-Man is running both in those clouds, and we can persist some data and view them from both instances of the game. So now let's say you have a new technical director, for example, and there's a new mandate that you now must run your application on Amazon Web Services and no longer on Microsoft Azure. Well, so now you need to migrate the game away from Microsoft Azure onto Amazon Web Services, and we can keep the Google Cloud Platform instance. So what will that look like? Well, we will basically have another Kubernetes cluster here on the left running on Amazon Web Services, registered with the Federation version 2 control plane. And we're basically going to get rid of Microsoft Azure and run the application on Amazon Web Services and Google Cloud Platform. And so we're going to migrate the application in 3 steps. The first step is we'll add the Pac-Man resources onto this AWS cluster. Once the resources are added, we will update the pacmanifontlabs.com DNS to remove the Microsoft Azure service DNS IP and update it to add the Amazon Web Services service IP and keep the Google Cloud Platform. Once the DNS has been updated, we can then remove the Pac-Man resources from the Microsoft Azure cluster. So let's go ahead and do that. So in order to add resources onto AWS, we can do that pretty easily by editing a resource type supported by the Federation version 2 control plane called Federated namespace placement. And this resource type basically indicates the namespace Pac-Man that you want and the rules that you want to specify on where that Pac-Man namespace should exist. So here you can see that we have the cluster names field, and we're specifying that the Pac-Man namespace should exist in Google's cloud platform, the cluster name GKUS West 1, and the Microsoft Azure cluster named AZ US Central 1. So in order to add AWS, let's just specify the AWS cluster name. We can save that, exit, and let's take a look at the pod situation after we make that change. So you can see that we have 5 instances of Pac-Man running here, 3 on Microsoft Azure, and now on the AWS cluster, we have 3 Pac-Man instances that are running, and they were created about 3 seconds ago. So now that we've gone ahead and updated the federated namespace placement to have the Pac-Man resources running on AWS, we go ahead and update the DNS. So you can see here I launched the command real quick because this can take a little bit of time in order to update. And this command will basically allow you to manually update the DNS for us. Now this is a tool that's just a temporary solution for now. We are working on implementing a DNS solution for Federation version 2 that would basically allow you to, or allow the ability to manage the DNS automatically and work with different DNS providers like Amazon's Route 53, Google Cloud DNS, Core DNS, so on and so forth, and allow the DNS entries to be updated in an automated fashion. So what this tool does is basically we're specifying that we want the DNS to be updated to reflect the Pac-Man service IPs for our Google Cloud cluster and our Amazon Web Services cluster. So you can see those clusters listed here. And what it basically does is it removes the IP addresses that currently exist for the pacmanifontlabs.com DNS, and it'll add a removal record for that, It's then going to wait for the dynamic DNS IP address to be reflected for Amazon Web Services. So if you're familiar with AWS services, they give you a dynamic DNS as part of their service load balancer, and that dynamic DNS will resolve to a particular IP address. So we're waiting for that IP address to be reflected. And once that's reflected, it will go ahead and use that IP address along with the IP address for Google Clouds, for the Pac-Man service running on Google Cloud, and create a record addition to the transaction. And then you can see the record addition there. And then it will go ahead and execute that transaction atomically so that we remove the IP addresses and add the new ones in an atomic fashion. And once that's done, we're basically just waiting for the DNS update to be propagated and to be reflected on this particular system that we're running on. And we're using the Google's public DNS server for this. So this particular step shouldn't take too long, but it can definitely take a little bit. So let's just wait for that to finish. And there you can see that the DNS is now reflected on this system. So once that's done, the DNS now points to AWS and Google's cloud. So we now have Pac-Man working on both of those clouds. So we can go ahead and remove the resources for Pac-Man running on Microsoft Azure's cloud. So let's go ahead and similarly, we'll edit the federated namespace placement resource type. And in the list of clusters, we now no longer want Microsoft Azure. So we can delete that cluster name and we'll keep Google Cloud and AWS. Save that. And we'll run the command to get the pods. And you can see here that we have the 5 Pac-Man instances running still on GKE, and we have Pac-Man instances that are being terminated in Microsoft Azure's cloud, and we have the 3 Pac-Man instances still running on AWS. If we run that again, we can see that we no longer have resources running. So the controller saw that update and propagated those changes accordingly. So now we've effectively migrated the application away from Microsoft Azure onto AWS while keeping our Pac-Man instances running on Google's cloud. So let's go ahead and play the game again and see what that looks like. So let's go ahead and refresh on the left here to get the new DNS updates. And on the right here, you can now see that we are running on AWS's cloud. And it's running in the US 1B zone there. So let's go ahead and play around. So you can see AWS was updated there on the left to show the live stats for this instance of the game. So let's go ahead and die. And we'll save this as Ivan 3. We can view the high score, and we see that Ivan 3 running on AWS with a high score of 820 was persisted. And we still have the high scores for the other 2 rounds that we previously played. So let's go ahead and update the game, refresh, and we can now see that we're still running on Google's cloud platform here. And similarly, we can go ahead and play another round. And you can see that the score there, the life stats are updated to reflect this latest instance here. We can go ahead and save this. Total score was 900. Save that as Ivan 4, and we can see that Ivan 4 was persisted, running on Google's cloud platform with a high score of 900. And you can see that all the other rounds that we played are still persisted there. So you can see that we were basically able to migrate the application from Microsoft Azure onto onto Amazon Web Services and keep the Google Cloud Platform still running. So if you're interested in more information, the Federation version 2 link to the repo is here. If you're interested in this Pac-Man migration demo, there's a link to that there. And there's also some other Pac-Man tutorials linked here as well if you're interested. So as you saw, we basically started with with Pac-Man running on Google's cloud platform and Microsoft Azure. We then migrated the Pac-Man application away from Microsoft Azure onto AWS, and while keeping the Google Cloud Platform instance running. And we basically did that by having the Federation version 2 control plane automate that for us. And we did not lose any data, and we did not lose any uptime. Thank you.